So in the previous session we were discussing about communication system, okay? Transmitter, receiver, and there is a channel to send it, and how a transducer converts either a pressure or a temperature into electrical signal. Then that electrical signal to carry it from the transmitter to receiver, if the path is very high, too distance is too high, then you have to do some kind of modulation so that you superimpose the base signal with a carrier signal of very high frequency, so the high frequency wave can travel long distance. So we do the modulation, then at the receiver end again we do the demodulation. Okay. So till that point we have discussed. Then we were discussing like what is the why do we need to do modulation? Okay. We were giving an analogy of a stone and a paper. Okay, if the paper is the base signal or the modulating wave, it cannot travel on its own. If you wrap it around a stone, which is the carrier wave, it can travel long distance. And another need of modulation is if you don't modulate, your size of the antenna has to be very high. Okay, so that I will explain with a numerical. Okay. So modulation, why it is required? So without modulation, the size of antenna will be very high. Okay. So we'll take one example. Okay. So for example, if you are transmitting an electromagnetic wave of frequency 20 kilohertz, okay. So let us say I have an electromagnetic wave whose frequency is equal to 20 kilohertz. Okay. Okay. So the wavelength of this electromagnetic wave corresponding to 20 kilohertz. So if frequency is equal to 20 kilohertz, its wavelength lambda will be equal to your lambda will be equal to 15 kilometer. Okay, so there is a relationship between the wavelength and frequency. Using that relationship, you can find out this lambda. Okay. So your lambda is now 15 kilometer, okay, right? So as per a thumb rule is like this, like the antenna size should be equal to at least lambda by 4, okay? Yeah. So the antenna size is equal to lambda by 4. Lambda by 4. Okay. So if you see here, it is like 15 kilometer divided by 4, which is equal to 3 by 4, so 3.75 kilometer. Okay. So having an antenna of this size is quite difficult, right? Yeah. Having an antenna of 3.75 kilometer, the structure will be so high that it cannot withstand the wind load, and a lot of structural problem will come into picture. Okay. So that is the reason such a long antenna is not possible to construct. So from structural point of view also, you cannot construct such a high antenna. Okay. So direct transmission of such baseband signal is not possible. So direct transmission of 20 kilohertz signal, like signal of such low frequency, is not possible. Yeah. Okay. So that's why we have to do modulation. Okay. So what we can do, we can obtain transmission with reasonable antenna length if the transmission frequency is high, okay. So yeah, so if we convert this transmission frequency from 20 kilohertz, let us say 20 kilohertz to 1 megahertz, okay. So if I mix it up with a carrier wave and make the resulting wave frequency, if I convert it into 1 megahertz, then for a 1 megahertz the lambda is equal to 300 meter, okay. So when frequency is equal to 1 megahertz, your lambda is equal to 300 meter, okay. So this then the size of antenna
lambda
will be
by 4.
Size of antenna will be lambda by 4, which is equal to 300 by 4 is equal to 75 meter, which is possible, okay. So therefore, in a need of transmitting information, we have to convert it into a very low frequency, okay. So that is one of the important thing, okay. So that's what we had discussed about modulation, okay. And then so the need of the modulation is size of the antenna is equal to wavelength lambda by 4, okay. And another important formula for numericals is like the effective power radiated by antenna is equal to and the L by lambda square, okay. So power radiated by antenna, is equal to P equal to L by lambda square. It is L by lambda square. This just remember, okay.
Yeah.
So if this is my antenna, okay. If this is my antenna, let us say this is the height, the length of my antenna, okay. So higher is the length, more is the power transmitted, and higher is the length, wavelength of the radio wave or electromagnetic wave, less is the power. So more is the frequency, less is the wavelength, more is the frequency, more is the power transmitted. Okay. So this is with the help of a numerical. There can be numericals like this. From this equation you can interpret. Okay. If the height of the antenna, why it is so important? Okay. Why to increase the frequency of the modulated wave?
Yeah.
That is because the more power will get transmitted and it will not get attenuated so easily. Okay. So this is about modulation and a numerical related to modulation. Okay. Then we are discussing like there are three ways of sending these signals. Okay, there are three ways. Okay, you can take a picture. Okay. Okay, so what are the different transmission medias? Okay, how do we transmit? What? So we have told that we have a transmitter, we have a transmitter, and then we have a medium of communication, right?
Yeah.
We have a transmitter, we have a receiver, and in between we have a channel. Okay. So we have a transmitter. Okay. So we have a transmitter, we have a channel, we have a receiver.
Yeah.
So these are the three things we have. Okay. And then before this transmitter, we have the information source. Okay. Information source. source. Okay, so we have an information source, and then similarly we have after the information source, again it will be demodulated, and then the user information, the final user, end user, he will use the information. So user information. And so these are five major components of a transmission system. These three are major. Okay, you have the transmitter, you have a channel, and you have a receiver. So this channel, okay, so this channel is the medium of transmission. So what are those channels? Okay, those channels, it can be either wired or wireless. Okay. So in this wired, we have there are various wired medium. One is your coaxial cable. Okay, coaxial cables. Okay. So you might have seen in our broadband communication, unless cable comes here, we cannot have the internet. Yeah. So those communications are like say wired communication through wiring. But at home, that wave, whatever your modem or that is transmitting, that can be wired or wireless. Okay? Yeah. But if you put wire, its speed will be very high. So if you connect your device with the modem directly with a wire, your speed will be very high. Okay. But in wireless communication, there is a chance that the speed will decrease. So you have wired medium. One is your coaxial cables. Okay, then you have fiber optic cable. Okay, you have fiber optic. That is called optical fiber optic cables. Okay. Yeah. So currently, you might have seen in UK we have maximum 20 Mbps. That time they were using fiber optic. So now here also over last few years we can see the speed has increased to even 500 Mbps, 1000 Mbps. So all this has been possible because of the fiber optics. Okay. So in coaxial cable, the maximum bandwidth that to which it can go is 750 megahertz. Okay. So here it can go up to 750 megahertz. Okay. Then so other than these two communication, there is wireless communication, which is otherwise called your space communication. Space. Okay. You don't need any wire or anything for that. This is space communication or the radio wave communication. The electromagnetic wave communication. Okay. So the frequency range for the coaxial cable is 750 megahertz. And then for the fiber optic, it can go from 1 terahertz to 1000 terahertz. You can see how 1 terahertz to 1000 terahertz. Very high frequency communication can happen. So you know that what is the advantage of having high frequency. If you have high frequency, your energy loss will be very less and the speed of travel will be very high. That's why you are able to achieve such internet speed because the fiber optic
has very high frequency.
Very high frequency. Okay. So this is fiber optic is related to like optics, theory of optics. That principle is being used there. Okay. So and optical fiber can give you an optical fiber can offer a transmission bandwidth in excess of 100 gigahertz. So the bandwidth of transmission will also be high with fiber optic. Okay. So now, so these are the things like wired communication. Then this is wireless communication. So in wireless communication, there are various radio waves that comes into picture, and they are divided into various frequency ranges. Okay, so you can take a picture, and then we will discuss about the electromagnetic waves and the radio wave communication. Mostly these satellite communications are radio waves. So the TV and whatever we are seeing, those are radio waves. Okay. So, wireless communication frequency bands. Okay. So, wireless communication frequency bands. So, what are the different frequency band that is being allotted for wireless communication? One is your AM or your amplitude modulation broadcast. Okay, AM broadcast. AM broadcasting. Okay, that is one. And then you have FM. I was telling there are two type of modulation. One is amplitude modulation. One is frequency modulation.
Yeah.
Okay. So in amplitude modulation, the amplitude of the modulated wave will be different.
Different, your
And
frequency.
frequency will be different. So FM broadcast, and then television broadcast, TV. Okay. So these are all radio, AM and FM. These are all radio. Then TV broadcast. So what are the frequency band allotted to these type of communications? Okay, this is what we are discussing. Then cellular mobile radio. Okay. Then you have satellite communication. Okay. Satellite. So what are the frequency ranges? For AM it is 540 to 1600 kilohertz. 540 to 1600 kilohertz. This is the frequency range. Then for FM it is 88 to 108 megahertz. 88 to 108 megahertz. Okay. Then TV you have 54 to 890 megahertz. 54 to 890 megahertz. Okay. Then cellular mobile radio 896 to 939. 896 to 935 megahertz. Okay. And then satellite communication, uplink, downlink, and all that. That is from 5 gigahertz to 5 to 7 gigahertz and all. 5 to 7 gigahertz. Okay. So these are just some standard numbers for different. So these are all wireless or the radio wave or electromagnetic wave. Radio wave, which are your electromagnetic wave, which does not need any medium. It can travel through space. Okay. So take a picture. Okay. Okay. So there are various ways of transmitting your electromagnetic wave. Okay, so we'll just draw one picture and we'll explain. Okay, so propagation of electromagnetic wave.